Welcome to Elemental Impact, where chemistry meets everyday life. Today we will talk about to understand chemistry's central place in our world, bridging the physical sciences with biology, medicine, engineering, and beyond. We must begin not in a modern laboratory, but in a far older one. Chemistry, often called the central science, owes this title to its unique power to explain the transformations of matter that lie at the heart of both natural processes and human innovation. Whether in the beating of a human heart or the forging of materials for space travel, chemistry provides the fundamental language to decode and reshape the world. But long before periodic tables or molecular models, there was a different kind of experimenter, one who worked by candlelight, guided by both ancient texts and philosophical questions about the nature of existence. To trace the roots of this science is to travel back over 1,000 years to a small laboratory in 9th century Baghdad. There, surrounded by copper stills, hand-blown glass flasks, and shelves of manuscripts, a solitary figure gently stirred a mixture of minerals and herbs over a flame. His name was Jabir ibn Hayyan, later known in Europe as Geber, an alchemist whose legacy would stretch far beyond his own era. Though his quest was famously mystical, seeking the elusive elixir of life, his most profound contribution was methodological. He laid the procedural and philosophical groundwork for what would become modern chemistry. Jabir worked during the Islamic Golden Age, a period of remarkable scientific and intellectual flourishing centered in Baghdad's House of Wisdom. It was here that scholars preserved and translated the scientific heritage of Greece, Persia, and India, building a vast corpus of knowledge. But Jabir went further than mere preservation. He synthesized these traditions into something new, a systematic framework for investigating and transforming matter. Much of his written work remains steeped in legend, and some of the vast corpus Jabirianum was likely authored by followers. Yet the principles reflected in his texts show a clear break from purely symbolic or mystical alchemy. Jabir pioneered a methodological approach, documenting procedures for distillation, crystallization, calcination, and sublimation. These are processes still taught in chemistry labs today, illustrating how deeply his influence runs. What distinguished Jabir most was his insistence on reproducibility. Unlike many early thinkers who wrapped transformation in allegory, Jabir offered detailed, testable instructions. He understood that true knowledge required procedures that others could follow and repeat, a core value in the scientific method. His theoretical outlook, rooted in the classical four elements, hot, cold, wet, and dry, was drawn from Aristotelian thought. Though now outdated, this framework represented a significant early attempt to describe chemical reactions in a rational, organized way. Even his fascination with numerology and symbolism, while misguided by modern standards, stemmed from a desire to uncover hidden patterns in nature, a belief that the universe followed knowable laws. In this way, Jabir's work not only anticipated the structure of chemical science but also mirrored the broader goals of chemistry in society, to understand the behavior of matter, to innovate through transformation, and to apply knowledge in service of human needs. When his writings reached Europe in the 12th century, translated into Latin, they helped ignite a new era of inquiry. Thinkers such as Albertus Magnus and Roger Bacon cited Geber as a foundational influence, particularly admiring his careful procedures and empirical spirit. His ideas became central to European alchemy and, eventually, to the birth of early modern science. So while Jabir ibn Hayyan never discovered the mythical elixir of life, his true legacy was something even more powerful, a new way of thinking about the material world. In a time when knowledge was often rooted in dogma or mysticism, he helped open the door to a different path, one based on observation, experimentation, and replication. In doing so, Jabir laid one of the first stones in the long road that would lead chemistry to its modern role as the central science, a discipline essential to both understanding and transforming our world.